Okay, Joshua's going to start his talk. Brilliant, thank you.
Okay. Thanks, folks. Can everybody hear me okay? Yeah. Good stuff. Okay, so thanks for coming. My name's Joshua Kite. I currently work at Credit Karma. Previously, I worked at DAZN, which is where most of the development for what I'm going to show here took place. It is an open source project. It didn't originate there. I brought it with me, and I was given support to develop it there. In fairness, I'll point out we're not using it at Credit Karma because we're a GCP shop. But it's still very much in use at DAZN, and I think Instacart are using it, and Endeavour Streaming Media are using it, and I forget who else. So what I'm going to be talking about is two threads. One is the specific, which is a Bastion, done entirely, essentially, with a Terraform plan and with nothing else. And the other thread is going to be about how I feel Terraform should be used successfully at scale. To give you an idea, at DAZN we had about 1,000 AWS accounts, so, 250 AWS accounts, but in about 4 regions each. So we were looking at about 1,000 odd environments, and we had those in an AWS organization. And at that level of scale, people messing about, oh, I'll do that bit by hand. No, you won't. You have to have it automated. And some of the features in this were a response to that. But definitely, this is something that is production hardened. So also here we're using Amazon's IAM-based authentication, which I'll come on to, so we don't have to worry about managing our own authentication method. Say again? I've lost video. Why have I lost video? Oh, that's handy, isn't it? Okay. Okay. Right, thank you. So, yeah, so this is me, my contact details. Unfortunately, I haven't got a separate presenter view, so that's why I'm juggling my phone at the same time. So, I'm going to presume no knowledge here, so forgive me if you know already this stuff. A Bastion is basically a secure instance that you will use for accessing your data center from the outside world. It acts as a secure point of contact. It's a hardened sort of gateway. Like you can think of a castle, fortress, for instance, and the idea is that this is the place where you manage access, rather than having all of your instances directly accessible from the internet. And typically, it's going to be something that's one of the first things that you set up with a new data center or a new VPC. It will be using a commodity Linux distribution. It'll be set up by hand because, oh, we haven't got around to terraforming stuff yet. It'll be running whatever the sysadmin's favorite distro of Linux is, like, I don't know, Arch or something funky that you wouldn't normally meet in an enterprise environment. And then you can set it up really quickly like that. And then you wind up in a situation where people will criticize you for using SSH and say, oh, it has no place, you should be managing everything by logging and monitoring and observability. But ultimately, when you are in development, you're going to want to be able to access things. Certainly stuff like databases, RDS instances. I think it is an extremely useful and versatile tool. So what's the bigger picture here? I don't know if you can see well at the back, but this is actually a picture of a Lego castle. Not one I actually built myself, but one I found a picture of on Google. And this I'm trying to underline the idea of not reinventing the wheel, using something a bit like the microservices approach you would have to software, of small reusable components that you can manage by configuration. And from that, you can scale out. So the idea almost like horizontal scaling, or like the components of a microprocessor itself. A huge number of logic gates. Each one is generic, but put together you can make a unique state. So a new Bastion server, you set it up, it's nice, pleasant, well-behaved thing. It kind of stays out of the way. It's transparent, and it's just dealing with access from one area to another. But the problem is, soon, before you know it, you've got yourself in a situation where everyone's been using the same shared login as, for instance, in Amazon EC2 user. Everyone's sharing the same key. Someone's installed a Python environment here and a different version of it over there. There's some Ruby stuff. You've got an Erlang fan on the staff. There's some Perl scripts. There's all sorts of ropey repos going on. And you can wind up in a... And then you might even have people doing things like setting up scripts for hopping onto their favorite SQL database with the root credentials, which are always handy. And all of this is on an instance that's managed by hand, hand-cranked, exposed to the public-facing internet, not patched, not managed. And before you know it, you're scared to even restart it because you don't know that it will come back up. And your release is going, the software release it's on is going out of support, and your laundry bills are going up, but you can't really do anything about it. So you can wind up in a situation where before long it's completely out of control, everything's everywhere, you've just got a huge mess of unknown configuration. Maybe you've set up separate accounts for your users, but if they've got root, you can't be sure that they will have used them. You basically have a real hard time. So I wanted to look at how else this could be done. And I don't pretend to be the first person to notice this issue or to try and suggest a solution for it. There are a few that keep popping up on my search, and I call these bastions on steroids. I'm not going to go into detail on these because the last time I researched them was a little while ago, so I don't want to give information that I can't be sure is current. And also I think it detracts a bit. Covering 3 or 4 different threads in one 25-minute presentation I think is really perhaps a little bit much. But the thing is that each of these sort of super Bastion servers wants to be the central source of authority. They often have multiple components, like their own MongoDB database, or they have additional features like session recording for shell sessions, which you may want, you may not. I didn't want it. They want to do 101 things, and they want to be the source of authority, and that's great if you have one Bastion server. But think back, we have 1,000 VPCs that we need to manage, and we have several hundred users that we need to manage with those. And any one of those users could have their keys compromised at any time. How are we going to roll it? This is not really a solution. So I tried to think of a design philosophy and how we could deal with this in rather a different way. So rather than looking at what we could do, I decided to initially look at what we could avoid doing. So this is the sort of opposite land way. First of all, though, we need to know what are our limitations. And I wanted it, from a client point of view, to be vanilla SSH, because vanilla SSH is widely supported. People think they understand it. It has all sorts of intricate features and foibles, but you don't really need to worry about that. If you're dealing with standard SSH, you're dealing with standard SSH. And although, for instance, PAM supports a pluggable architecture, I didn't want to be patching anything or trying to manage security myself. This is a golden don't do rule, rolling your own security. I didn't want to require integration with something like Active Directory or LDAP, because the last 2 places I've worked, the IT team were completely separate from the sort of software engineering and infrastructure team. the link between them wasn't very good, and something like 6 days turnaround to have a user account changed is not something you can deal with when you've got something like the heavyweight world boxing championship and someone's keys have been compromised and you need to roll them now, right now. Yeah, I didn't want that. So what did we do?
Sorry about that.
So if you, taking again that example of turning things backwards, has precedence, has form. Here's something from Linus Torvalds
Yeah, I'll just
on
back in
originating the idea for Git. Just turn it around and do the opposite. Look through the wrong end of the telescope.
I don't mind.
Here's another example. Japanese flower arranging. Space is as important as the objects, the greenery is as important as the flowers, and in some schools the container, which we'll come back onto, is as important as the arrangement. So, presuming that a completely secure server doesn't exist, we'll have a Bastion server that only exists when we need it to. And secrets management is tough. So let's try not to manage any secrets, if we can avoid it. And security is tough. And security software can be really even tougher than that. So let's not manage that either if we can avoid it. User management can be painful. Let's avoid having to manage our users if we can. You can see that I've got an operational background here. I'm starting off by like, throw that out, throw that out, throw that out. I don't want to be doing with that really. And build chains. Some people can get really in love with their build chains and their build pipelines, and that's great. And then you move to a different shop where, I don't know, they use Circle CI and you like Jenkins, or they use Drone and you like, I don't know, GitLab or something, and everything goes out the window. So I didn't want a reliance on a build chain. And then those can have all sorts of issues of themselves. Container registries, if anyone's ever tried looking for anything on Docker Hub, at best it's a bit of a faff, and I could never find anything on there. And again, I didn't want to have a separate requirement. So much for what we want to avoid and what we don't want. What do we aim for? I wanted something that would be like SSH Bastion as a service. And if you use anything like, if you've used GCP with things like gcloud, compute, SSH, I think is the command, or Cloud Shell. It gives you a sort of hostless Bastion type service, which can be great. At that time I hadn't used it, but I wanted something for AWS. I didn't want something that required an agent though, because things like gcloud Connect and AWS CLI and so on, they all, require an instance to run on that can support that, typically a Python framework, and connect to something at the other end that is also running some framework. Whereas with vanilla SSH, you don't need to worry about software support. If you want to access it from your phone or something, you can just download a SSH client and you can use that. So I wanted something that would be as light as possible, renewed frequently, hinder persistent exploits and unsanctioned customization. Really cattle versus pets. Perhaps running as containers with each instance being called on demand for each connection, and then being destroyed once that connection was over. So this would also have the happy synergy of compelling an external source of authority for user identities, avoid the jump boxes being used for anything else, like all of the root passwords and funky frameworks and everything else. And also, it would be nice by making it stateless to have it so that you could just redeploy and again have latest version of everything. And of course, it would be nice to scale it so that users would ideally have an arbitrary number of connections. So, unsurprisingly, I decided on Docker as a containerization framework to use. It's the most popular one, I think, at the moment. I know that there are others. I'll be honest, I haven't worked with them. Docker was friendly and it was enough for this project. What's happening here is users are logging into a Docker container and using it interactively. It's very fast and it's trivial to duplicate instances. We control those instances, we trigger them with systemd. So systemd allows you to have socket-activated systemd units, and it's a bit like the old inetd or cosinetd super server. Basically what happens is you make a connection attempt to the server, that connection attempt causes a new systemd unit to be spawned from a systemd unit template, and that systemd unit can be anything. In our case, it is a Docker container. But what this means is you can scale out to the limit of your host resources to have an arbitrary number of Docker containers running with an arbitrary number of connections ostensibly on the same port in a similar kind of model to how you might do with a web server. I know that systemd has died down a bit now, has attracted a lot of hate in the past, but frankly it's part of the landscape and I am pragmatic. That's what there is. We're not using here any standalone orchestrator or scheduler. So what are users logging in with? AWS has a sort of Git service called code commit, and last I checked you could store up to 5 SSH public keys with them, which you can query via an API. This is about the only secret pair, certainly at the time, that AWS had that you could have that was user configurable and could be called via an API. They have improved the landscape a little bit, but I still am not aware of one that is a pair. I know this reInvent, I think, is still going on, so knowing my luck, they'll have announced something 10 seconds before I got on the stage. But yeah, things like OpenVPN certificates and stuff like that, or what have you, it's much more difficult to manage. An SSH key is easy. So what we do is we query, when the container launches, 1 container per connection attempt, we query AWS for all users who have an IAM identity and have 1 or more public SSH keys stored, and then we generate local Linux user accounts for them with those public SSH keys inside the container. So by the time they actually get to the container, it's very much like a traditional bare bones Linux server with a bunch of home directories and a bunch of public SSH keys on it. We use terraform to deploy. So this allows trivial recreation of an arbitrary number of service host instances. It's great for things like dynamically interrogating the environment, selecting the latest OS patch release for an EC2 host. You can use it for things like setting DNS entries per environment, interpolating user data, which is also something that is used here. And although you wouldn't normally bother setting a host name on a Docker container, here it's useful because we're dealing with a lot of regions and a lot of AWS accounts, and it's useful to have a prompt so that people know which container they are logging into. And also you can use state outputs from other plans. So if you've been a good person and you've used remote state, then you can interrogate the remote state from one plan when you are deploying your next plan. So the 2 plans can be run independently, but you can take the outputs of one and use them as the inputs for the next. I didn't think I still had this slide in here. I'm going to skip past this because this one is not relevant. If you use AWS organizations, that's cool. We can assume role within our container for the query to AWS so that it assumes a role into another account to get the users from that account. And this is the way we were managing it at DAZN. We had a master account which had all of our user identities in it, and then all of the other groups of accounts per development team would not have any user identities in them. They just had roles, which could be assumed based on the roles in the master account. How do we scale? Well, you can have users in groups. This is an optional feature. I'll be honest, I got it for free. The Golang code that's used here was made available by another project, so I reused it. And also, intrinsically, this design is high availability, so it's intended for things like a multi-availability zone deployment with a load, so there's a load balancer, there's an auto-scaling group, and there's everything in there. Now, one thing that could happen at a very large scale deployment is you get IAM rate limiting from AWS. We got up to something ridiculous like 8,000 IAM queries in a 24-hour period. Or was it 80,000? I forget. I think it was 80,000. And then we start getting rate limited. So we had to swap out some of the logic at that point. What does this look like to a user? Well, very straightforward. Please ignore the bit about the ECS host here. That's a reference to a previous incarnation of this presentation, where I was also talking about stateful instances, but I'm not going to linger on that here. So trying to explain this to users was initially a bit of a problem, and what I would call an XY problem. Explaining to users in AWS that you are not using a PEM. You're using an ordinary SSH key, and you can generate it yourself, and you don't have to show anyone else the private key. You only share the public key. You manage it yourself. Yes, the administrator can delete it for you, or can post the public key for you, or put it into your new user funky setup tool that you would get in a decent large organization, but it doesn't matter. You still don't have to do that, which is great. It's self-managed, which is great. And I do have a slide here for what this looks like, but I'm going to resist going into a lot of detail here. Basically, this is a sequence diagram excuse me, showing going across from the Bastion service host, assuming a role, firing up a container, assuming a role, getting all of the user identities, creating them, the user goes into there, and then they can go on to the next step in their process. So what does the code look like? It's open source, it's under an MIT license, and you are welcome to download it and play with it for yourself. It's available on GitHub. It's also available on the Terraform module registry, which I find very convenient. It's a nice place to look for Terraform modules that have... It's not that there's any user review or peer review on those modules, really, but they are collected by theme. You can search it. You can see, you know it's all Terraform. You know it's all in one place. And even if you're working in a, should we say, a higher security environment that won't use remote modules, such as my current employer, you can still see things there that can be useful to take away and put into your own plans. What the code doesn't do is almost as important as what it does do. It's completely self-contained in one Terraform plan, which can be called as a community module. But there are options, there's lots of options in this one to swap in your own components if you want to. But you don't have to use them. You don't have to go into the ins and outs of everything. It's provided for you in this plan. And you get an immutable deployment of the latest patch release of each component. So the latest, because the Docker container is actually built from within user data at deployment time, by default, you don't have to really know or understand anything about Docker to use it. If you do, and you want to, you can swap that out for your own Docker container, or you can put a completely different authentication mechanism in from AWS IAM if you want to, but you don't have to. So the bar to entry is very low here. It simply have an AWS account. You get instantaneous access. You don't have to have any extra user management, just whatever is in AWS IAM. We have time-limited containers with reverse uptime, which is a good security practice. So although users by default will have root when they log into the container, it's root within the container. And their lifetime is limited to 12 hours. So they can do whatever they want in there for those 12 hours or until they close the connection, and then it's gone. And every time they connect, they connect to a Bastion that is in a known state. By default, they get an Ubuntu userland on a Debian host. You can reverse those or put them in a different combination if you want to, and I expect to have to review the code, what is it, April, when the next LTS is out for Ubuntu. And as I said, it's under MIT license. So, no, really, people are maybe thinking, what does the code look like? This is a complete Terraform plan. Probably the simplest one you'll see today. That is literally all you need to deploy 19 AWS resources, in an EC2 instance in an auto-scaling group with the Docker container within it and the Golang code that will hook into AWS IAM. Here, it's just the example. It's a free example. It was a community contribution. I didn't write it. Someone kindly made it available. And by default, this will deploy in Ireland, EU West 2, and it will be open to the world. So you can log in from anywhere to the instance that in your AWS account. You'll need to collect the load balancer DNS name from your AWS account in order to access it. And I'm afraid that, although I was hoping to demonstrate this tonight, I'm not going to be able to for complicated corporate reasons that I won't bore you with. But seriously, this is as simple as a plan can be, and this brings me on to back to the other thread of this presentation, which is using small components reusably. I've seen a lot of instances where people want to take Terraform and build a gigantic monolith. I don't like monoliths. They were a bad idea in software design. If you're doing infrastructure as software, infrastructure as code, the same paradigms apply. You want to manage by configuration. You don't necessarily need 100 options. You don't necessarily need loads of resources in there. But fundamentally, any Terraform plan can be called as a Terraform module. So you can concatenate, or rather think of a Euler diagram where you have one inside another, like a Russian doll. I think it's pronounced matrushka. I probably garbled that. If there are any Russian speakers here, I apologize for the mispronunciation. But this is all you need to get started. Your own Terraform plan can look like this. When I was at the Zone, we would have a system, and it's still in use because I know they're still using this, this module. You would supply as input the AWS account number, and from there everything would go out across all of the regions, all of the roles, all of the ECS clusters, all of the bastions, all of the RDS database instances. Everything could be put in its place because it would look up the outputs from the previous plan to the next one we would deploy in layers. But here, this assumes nothing but a vanilla AWS account. You don't have to have anything in it to run this example. That's all you need. Of course, this is intended as just an example to get you started, but it does show you how you can deploy rapidly and repeatedly, because the submodule here is the public module that is called, so although the example is sort of a subdirectory of the, in the Git repo, here, of course, that's the main module, and then it calls the main repo as a child. So, reflections. Since this Bastion service host isn't running anything interesting beside the Dockerized service, It doesn't really matter if our users can see the metadata, and we're not overly worried about a guest escape. Unlike traditional Bastion servers, our users are protected from SSH socket stealing, identity impersonation. There was recently a bit of a scare on, I think I saw something on Reddit NetSec about this recently, and I just thought this is old news. And reflections on using this approach to modules. So I've spoken already about using the sort of micro-component effect or paradigm toward infrastructure, and trying to break away from this awful monolith that becomes common. I freely admit that not everyone will want to do a live pull from a third-party site to deploy their own infrastructure, especially something they're relying on for security. But the principle is the same. You can put a Terraform module anywhere. You can have it on an NFS share, you can have it on a directory, you can have it in Git, you can have it in whatever your version control system is. It doesn't really matter. It's very flexible. Here, yes, I'm showing you Terraform module registry, or from GitHub, because those are the common sort of default ones, or the ones that are best suited. You can have it from anywhere. The principle is the same. I would really strongly urge people not to put all their modules in a subdirectory in a giant Terraform plan that's 450 megabytes, like I have experienced. I didn't know that such things existed in times past, and I think maybe that I look back fondly to that happier time when I didn't know that these things existed. But be the change you want to see in the world. Don't do that. Use external modules if you can for anything complicated, and I would argue that this increases your agility, your velocity for implementing new features, and it tends you toward a loose rather than a close coupling of components where you can have a situationally specific configuration via variables rather than a static monolith. Thank you very much. Did we have time for questions?
Yep, definitely.
I think that was 32 minutes.
I know this might predate when this product was created.
I'm sorry, I can't hear you clearly.
I know this might predate from when this product was created, but isn't it more advantageous to use EC2 Instance Connect?
Well, the problem with EC2 Instance Connect, like all of these agents, like gcloud SSH Connect and the AWS CLI, they all require an agent to be running on the host, and they all require an agent to be running on the client that you're connecting from.
No, it's just your plain vanilla SSH client that talks with a wrapper in front of it, but it's still MSSH.
So what does the wrapper run on? Can I install it on Android?
Yes.
Can I install it on an iPhone?
Never tried.
Okay, I don't know. At the time...
It's just a wrapper on SSH, which is MSSH, and just talks to the API on AWS, and the session is managed by the API, and then you end up on a TTI.
Okay, I haven't come across this, so I can't really comment. What I will say is that when I looked at the first incarnation of this, it was lacking in some features, and it was difficult for things where you didn't have an agent at one end or the other. I mean, I've wound up extending this idea into things like VPN equivalents, and it's not always a practical game to say, well, there's always going to be this agent or that. This, I can't comment because I'm not familiar with it.
My second question is, where do you manage the keys for the user? So you have the private keys on the user, they generate self-service.
So
how do they publish the public keys into the system in an authoritative way?
So on AWS, if you go to the IAM page, there's a section there for public SSH keys. It's intended for AWS code commit, and that's where the keys go. Unfortunately, I cannot demonstrate because I'd hoped to use my own laptop to demonstrate, and I've not been able to do so, so I've had to share it with my work laptop, and because I am working for a fintech company, the security here is quite tight, and I don't want to mix the two. So I apologise that I've been unable to do that on this occasion.
More of a social question than a technical one, but how much pushback did you get from the users of these bastions in terms of not being able to really customize their environment and sort of install tools, that kind of thing? Was that a big problem?
No, it wasn't. The biggest issue was the novelty and trying to explain to them what it was and how it was different. But very much from the beginning, I wanted them to have freedom. So this is personal philosophy. You log into this Bastion, you have root. You're in an Ubuntu instance, and you can install anything you like, but only for 12 hours. Because we had a very strong commitment to deployment via code. So if you wanted to deploy into production, you had to go through the pipeline. There was no write access to production. So yes, in development, you could do whatever you wanted. But you weren't ever going to deploy anything. And then it kind of fell naturally into place. People would wind up with their own scripts that would do a sort of one-shot SSH command, install all of my funky BS thing here, and then open a connection. I think the most intractable one we had was some users who were trying to use auto SSH, which is, I will warn you now, is not a good mix with this. It creates an SSH reverse tunnel with the idea of keeping a connection open and stopping it timing out when you can't reconfigure the SSHD host. But in this case, because the user would always get a new tunnel coming in, the exiting tunnel would just be left orphaned, and it couldn't be connected to. It's almost like a zombie process. So when they kept doing this every 5 minutes, eventually you run out of host resources, so you have to wait until it kills them all after 12 hours. There is an option to have access to the host in this plan as well, but by default it's not there, it's not encouraged.
So your story about the auto SSH kind of leads on to my question. Do you have any kind of mitigation, given that this is obviously an internet-facing server, to prevent or work around DDoS attacks or script kiddies from Russia that are hitting your SSH service with dictionary attacks against every man and their dog? Do you integrate with anything like fail to ban or anything like that?
That's a very good question. So one of the weaknesses of this system is the possibility of a DDoS attack of this sort. So what we wound up doing was there is an equivalent project. It's not the same. It's written in a different language. It's also for AWS by Widix, I think it's called, which is where some of the references for ECS on this came from. So we had a stateful host where it would be working with so essentially all users had to go through a double Bastion in this sense, because our IT team at that time in that location were not able to support a proper domain integrated VPN. We had two steps. So we had one which was a very static stateful Bastion, which would not allow any interaction, basically. Yes, you could have an interactive shell, but you could have no home directory, you could have no privileges, we would wipe it, all this sort of stuff. And then to go into each of the additional accounts, you would go into one of these containerized bastions. So we had the office IPs whitelisted and the sort of the tunnel server, as we called it, whitelisted. No, that is a weakness of this design. It comes with a big benefit, but...
Thank you very much.
Thank you.